Okay, today with 3.2, we're going to expand a little bit on that mapping idea that we talked about yesterday, whether it's a function or not. So the first thing is pretty visual. It's called the vertical line test. If any vertical line passes through the graph more than once, the relation is not a function. Okay, so what you're going to be doing here, okay, if a vertical line passes through the graph more than once, if the line passes through the graph once and only once, the relation is a function. So that's at any point. So first of all, the vertical line is up and down. Now, sometimes we have to be very specific on where this vertical line test is happening. Okay, if we can see over here, so relation 1 is clearly just a straight line here going a little bit at a slant. It's a negative slope. It's pretty steep. This green line is our vertical line test. You're seeing how many times it hits that blue graph. It's happening only once there. It's happening only once there. With this blue line going from left to right, a line never bends, never changes directions, never comes back around. That line is never going to be hit twice by a vertical line, right? So no matter where we test this blue line, this relation, it's only going to hit once. So it is a function. Okay? Now, this next one, this graph, which you guys have seen a little bit of, and you'll see a lot more of in later in the semester here and into Algebra 2, where this is pretty much where you start. It's called a parabola. Okay? It's a very common graph. It happens when you're graphing squared functions. And once again, no matter where we test this, okay, it looks like it might be hitting it in a bunch of spots up here on the left and the right, but I promise you it's not. Okay, this blue line, if we zoomed in really, really close on any part of this blue line, okay, you would see that it's still kind of going up and to the right. It's always going to be going up and to the left or up and to the right. At no point is this line bending or coming back in on itself. So this is kind of a tricky one just because visually it looks like it's happening all over the place, but there really is only one point of intersection no matter where we're looking. So this is a function as well. Where you're going to end up with something that's not a function, for example, is a circle. Okay? If we end up with this circle, right, there are spots on the graph where it's hitting more than once, most of the graph. Now, one of the arguments you could say is, well, what about over here on the edge where I draw a line and it's only touching the side of it? That's only once. Does that make it a function? No, if there's ever a point, if there is ever a vertical line that goes through it more than once, even if there's a graph where that just happens once in the entire graph, if there's ever a line, a vertical line that hits that graph more than one time, you do not have a function. Okay? So when we go down here and look at these examples, over here, this blue line, that's a straight line going from left to right. No matter where we test it, it's only hitting once. That is a function. This second one over here, it looks like a parabola. It's tilted on its side. Again, some of you might say, well, what about that line that hits just that one point and it just goes by? That only hits it once. You're right. But everywhere else, you're hitting it more than once. Okay, remember, we're only doing vertical lines too, up and down. So this is not a function. And then this graph over here, this is actually what the graph of a absolute value looks like. Looks like a V. No matter where I test this one out, it's only going to be hitting once. That one is a function as well. Okay, so then we go over here. A function is a relation in which each element of the domain is paired with exactly one element in the range. So this is kind of the number approach to what we just saw visually. Okay, so with this mapping diagram, what we talked about yesterday a little bit, Here you see each of these domain values are only assigned to one range value. And this is a goofy looking graph, but if we did a vertical line test on it, that would be a function because there's never a point where we're hitting that line twice. So now we're focusing on the mapping version of this, okay? So now what it looks like when we're mapping is if you end up with any domain value that is going to two different range values, you would not have a function. But in this case, I've got -4 going to -1, -2 is only going to 3, 2 is only going to 3, and 5 is only going to 6. This, where you have multiple terms going to a single range value, that's okay. All right? That would be like a function of like y, like for example, y equals 0x plus 4. No matter what I plug in for x there, I'm going to keep getting 4 for my answer, right? If I plug in a 1 for x, I'm going to get y equals 0 times 1 plus 4. 0 times anything is 0. 0 plus 4 equals y. Okay? If I plug in 2 for x, y equals 0 times 2 plus 4. 0 times anything is 0. My y again equals 4. Your table in this situation, or your mapping diagram, would look like this. I would have an x of a 1 and a 2, and then my range only has a 4 in it. Both those numbers are going to 4, but that's okay. This is a function. I just made an equation for it. Okay? So you want to make sure that we're recognizing this is okay. All right? If we have a number that's going to two different y values, that's when we can't have that. Okay? So my domain here, notice your x values. I've got a 2 that's paired up with a 3. I've got another 2 paired up with a -3. That can't happen. Okay? So this one over here, yes, it is a function. The one in the middle, no, it is not a function. And then on the right side, again, I've got a 4 paired up with a 7 and a 4 paired up with a 13. That cannot happen. That one is no as well. And here's why. Okay, I'll make an example very similar to the one we just looked at in green. So here's why that can't happen. That's like saying if I have y equals 2x plus 2, and I plug in x equals 3. Okay, if I plug in x equals 3, I have y equals 2 times 3 plus 2. That's going to be 6 plus 2, and that's going to equal 8. Every time you plug in 3 into that equation, you will be getting 8. 2 times 3 is always going to be 6. 6 plus 2 is always going to be 8. That's like saying up here, when we have a 4 going to a 7 and a 4 going to a 13, or we have 2 going to 3 and 2 going to -3, that's like saying I plug 3 in for this x over and over again 5 straight times and I get 8. And then on the 6th time, if I plug in x for 3 for x, and all of a sudden 2 times 3 plus 2, and I find out that 2 times 3 all of a sudden is 10, and then 10 plus 2 equals 12, that's not possible, right? 2 times 3 is never going to give me 10. Every time you plug in 3 for x, you're always going to get 8 in this function. So if you find out that your x of 3 is paired with some other y, like 12, that's not possible. Okay? So that's why that's the case. When we have a mapping diagram here, this is a perfect visual representation of that. So remember, my domain is my x's, my range is my y's. My 2 is only going to my 5. That's good. Here I've got the 3 going to 5 and 0. That cannot happen. I can't have an x value that goes to two different y's, and we just talked about why that is in that last example. So once that happens, it is not a function. It doesn't matter what the rest of them are. And actually the 5 and the 9 are good. Those are both okay, but it does not matter. Once you have that one instance where it doesn't make sense, where that x value is going to different y's, it doesn't matter. So really all you need to be looking at, -2 is only going to 8, -1 is only going to 2, 0 is only going to 8, 1 is only going to 4, 2 is only going to 2. Again, this is okay to have multiple numbers going to the same y. That's okay. It just can't happen where one x goes to different y's. So this one then would be yes, it is a function. Okay? Down here, you're looking at the same type of thing. You're just paying attention to what those x's are doing. I have a 3 that's paired with a 7. I don't see any other 3. Really, you could make a mapping diagram for these different types of examples. To me, the mapping diagram is the easiest to see. So I've got a 3, a 5, and a 1. Remember, when I make my domain, I don't list my x's more than once, right? So the 1 is in there more than once. I don't list it more than once. And then my range is 7, 2, 4, and 9. 7, 2, 4, and 9. So let's draw the map. I've got 3 going to 7, I've got 5 going to 2, I've got 1 going to 4, and I've got 1 going to 9. That cannot happen, so this is not a function. Okay? Over here, I've got a -4 going to a 2. I don't have any other -4s. I've got -3 going to 3. I don't have any other -3s up top. 0, 2, and 5. I don't have any x's that repeat, so there's no chance that any x is going to 2 different spots. And again, you can make a mapping diagram just like that one to help you see that a little more easily. Okay? Find the domain and range, make a table to determine if it's a function. This is exactly what we're talking about here. Okay? Our domain is 1, 2, 3, 4, 5. Our range are all those values. I'm getting that from here. These are the teams. So the domains are team 1, 2, nope, 2 down here, 3, 4, 5, and then those different numbers, their distances of their jump, that's where the range is coming in. Okay? So you could make a mapping diagram, or you can map it out of these two sets here real quick. Team 4 goes to 19.4. So 4 goes to 19.4. 5 goes to 20.2. Team 1 goes to 20.6. Right there. Team 3 goes to 20.9. And team 2 goes to 21.5. And you can see that none of these x's are going to more than one y value. So this would be yes. Down here, okay? If it's a line going in both directions, from left to right, that line's going down and to the left forever, up and to the right forever. The domain is all reals. It's going to cover every single number on that x-axis. And the range, it's going to go up forever and down forever. The range is also all reals. So it's going to be really hard to make a mapping diagram of that. But remember, we also have the vertical line test. And a vertical line is never going to hit this graph more than once. So we end up with another yes, that is a function. Okay, so I'm almost out of time for this recording. We have 2 more examples here. I'll make another recording. There will be a part 2 that you guys see on your checklist. And then that's going to be it for the videos for the lesson. So I don't want to rush through these last 2 in the last minute. So this one's done now, and head over to part 2.